Okay, let's do another football problem. So let's say that we got a quarterback and he's throwing a football, and we want the receiver to catch the football at the same height that it leaves the quarterback's hands. Okay. We're going to throw at an angle of 34 degrees, and the receiver is going to be a distance of 17 yards away. So what we want to do is I want to know what initial velocity does the quarterback have to throw the ball in order for the receiver to catch it at that same height, a distance of 17 yards away. Okay, so we look at this and say, well, gosh, how do we do this problem? Well, first of all, we know that the acceleration is going to be g. We know g in feet per second squared, so we want to convert this into feet. So that turns out to be equal to 51 feet. All right. So we know that x equals x naught plus vx naught t plus 1/2 ax t squared. Y equals y naught plus vy naught t plus 1/2 ay t squared. If I put my origin right here, say that direction is positive x, up is positive y, x naught, y naught are 0, there's no x acceleration, so x is just going to be vx naught t, and y is going to be vy naught t minus 1/2 gt squared, minus because I said up is positive. Okay, and so we look at this and say, well, gosh, what do we know? We know x. We know y, because y is 0, because I said that we're catching at the same height. Okay, and we know g, and obviously 1/2 g. So, well, gosh, now what? Well, same situation as in the previous example. Not know v naught, but we need vx naught and vy naught. We know that vx naught is v naught times cosine of the angle, and vy naught is going to be v naught sine of the angle. Well, we know the angle. The angle was 34 degrees. So that means we do know this angle. And so we can plug this into the equations we just had. So x is going to be v naught cosine of the angle times t, and y is going to be equal to v naught sine theta times t minus 1/2 g t squared. But we know that's equal to 0. Okay, so that means we can actually factor out a t here. So we can factor out a t, so v naught sine theta minus 1/2 gt. Okay, and we say, okay, what do we know? We know x. Okay, we know the angle. Know this. And we said, well, gosh, we're now down to two equations, two unknown, v naught and t. So we can solve here and say, well, if I solve for this, then we can say that t here, we can solve for t, so move that to the other side of the equation. 1/2 gt equals v naught sine theta, so t equals 2 v naught sine theta over g. If I plug that into the other equation, x equals v naught times 2 v naught sine theta cosine theta divided by g. So we do a little bit of algebra here, and we say we're going to isolate the v naught on one side of the equation. And so after we do some algebra, then this comes out to be that v naught squared is equal to gx divided by 2 sine theta cosine theta. Oh, wait a minute. 2 sine theta cosine theta down here. 2 sine theta cosine theta, you remember, is a trig identity. Okay, that's sine 2 theta. Okay, so that can simplify our equation a little bit. So V naught squared equals gx divided by sine 2 theta. So V naught is going to be the square root gx over sine 2 theta. So V naught is going to be equal to the square root of 32.2 feet per second squared, okay, times 51 feet divided by sine of 68 degrees. So it'll be 2 theta. So V naught is going to be 42.1 feet per second. Okay. And so the quarterback has to figure out this and do it all in his head and do all the algebra and the square roots in his head without a calculator. So while they're in the huddle discussing this with the receiver. So maybe that's why they make so much money. So at least that's one theory. All right. So at any rate, so this is the idea here of how you do this. And obviously, if you had to do it for different height than you catch, there'd be extra terms, but you do it the same basic way. You set up the equations and solve. Basically, what do you know? What do you not know? Do algebra. What's the relationship between these things? You know, in this case, we had to go back to the relationship between the x and the y components. But so we're using the stuff from chapter 3 in there. But this is all basically the same equations over and over again.